Alright, on this first problem we have this loop of current that we have to integrate around using the Biot-Savart law. This big integral, or this integral down here, we integrate over the wire in the direction of the current all the way around. And you're probably asking yourself, how do we do that? Well, I'm going to save myself some typing in this. We have to divide it up into pieces. So there's the left end, there's the outer loop, there's the right end or bottom end, and then there's the inner loop. And we have to divide it up into these pieces because we can easily integrate on each one of these. Because here R varies, but phi, the angle phi, is constant, right? So phi is this direction, right? R is out this way or away from point P. And here phi varies, but R is constant. And again here R varies, but phi is constant. Phi varies, R is constant. All right? So we can divide it into these four pieces and go over the left end, outer loop, right end, inner loop, in the direction of the current. Well, how do we then do this? How do we evaluate, among other things, what's dl cross r hat? Well, dl is a little differential step in the direction of the current, right? And r hat is a unit vector that points from that little segment back towards point P. So you can see here the angle between dl and r hat on this segment is 180 degrees. And as you know, right, the cross product goes as the sine of the angle times the magnitude of the vectors. Well, sine of 180 degrees is 0. So we've eliminated that term because the cross product is 0 along that end. Right? And if we go over here, dl is in the direction, is in that direction. Well, r hat is also in that direction. Now we're looking at the sine of 0 degrees. Right? Sine of 0 degrees, also 0, and so we've eliminated that term. So we've eliminated two terms from this integral, and all we have to worry about is integral along the outer loop and the inner loop, right? So I'm going to copy, paste, delete terms. Okay, so now we have our outer loop and our inner loop, and we have to begin to worry about or figure out how to evaluate each of these pieces. Well, let's start with the outer loop. dl in the outer loop is in this direction, right? And it is always perpendicular to r hat, which points back towards the center of the arc that we're making there. So these are perpendicular, and the cross product goes from dl to r hat, right, that direction. Well, by the right hand rule, if you stick your thumb in the direction of your right thumb in the direction of dl, right, and you stick your right forefinger, and I got to contort a little bit and turn your back on the screen, right forefinger in the direction of r hat, and put your middle finger out perpendicular to those two, your middle finger points in the direction of the cross product, which in this case is into the screen. R in the minus k hat direction is the result of that cross product. Right? So in the outer loop, dl cross r hat is going to be dl minus k hat, all right, or minus dl k hat. Right? In the inner loop, dl is in this direction, r hat is in that direction. So if you look in the inner loop, we've got dl, we have r hat. You go through the same process, thumb up in the direction of dl, forefinger in the direction of r hat, your middle finger perpendicular to them, and in this case it's coming out of the screen at us, or in the positive k hat direction. Right? So along the outer loop, it's in the minus k hat direction, and along the inner loop, it's in the plus k hat direction. So let's go write this again. Let me type. Outer loop. DL cross R hat. All right, we got to, it is minus DL K hat in the outer loop. Now, we need to turn this DL into d phi, right? So a step along an arc, right? What is the length of a step along an arc? It's equal to R times the change in angle. And so out here on the outer loop, which way is DL heading? It's in the minus phi direction. So minus d phi, right? DL is minus R d phi k hat, right? So we got minus R d phi k hat minus, and stick that in place of minus DL, right? So, oh, sorry, k hat isn't there, right? DL is minus R d phi along the outer loop, right? And so the whole integral I DL R hat, put that whole thing over R squared, all right? What do we get to? This is going to be, we've got minus and a minus, right? So we've got a minus here and a minus there. So there's going to be a plus I R, well, R on the outer loop is what? It's B, right? D phi k hat over B squared. Well, one of those B's is going to go away. And so on the outer loop, we've got I d phi k hat over B. Right? That's what we're integrating on over on the outer loop. Let's just go ahead and do that integral. Well, we're integrating from where to where? From out here to there. And so we're going from pi over 2 to 0, right, of I d phi k hat over B, which is just going to end up being, so d phi is the only variable here. This is I k hat over B is a constant. D phi is going to go from pi over 2 to 0, so this is going to be evaluated at 0 minus pi over 2, and so we're going to just get a minus I k hat over B onto pi over 2. Right? Simple enough on the outer loop. Now the inner loop. On the inner loop, we got to DL. DL cross R hat is plus DL K hat. Right? And on the inner loop, DL is R d phi. K hat. Right? R d phi K hat. We stick all of this together. Our integral is going to be from 0 to pi over 2, because we're going, you know, in the inner loop, we're going from 0 to pi over 2, right? 0 to pi over 2. We have here I R d phi. Well, R is just A, and the A is going to cancel with the A squared in the bottom, so I d phi K hat over A. Right? And that's just going to end up being I over I K hat over a onto pi over 2. So for the outer loop, we got minus I k hat over b onto pi over 2. And for the inner loop, we got plus I k hat over a over pi over 2. So we put these two together. We've got to remember out front, we have a mu naught over 4 pi, multiplying it all together. So total onto Alright, so the pi's cancel out. We got mu naught over 8 onto I onto 1 over a minus 1 over b in the k hat direction. And that's it for this first problem.